This is Module 9. We're going through Example 8. It says, in a random sample, 1,011 adult Americans were asked if they consume alcoholic beverages. 647 of them said that they did. Part A asked us to use the 2SD method to find an approximation of the 95% confidence interval. So before I dive into Part A here, let's just note a couple things. This is a categorical sample. They have a sample size of n equals 1,011, and they asked each observational unit, do you consume alcoholic beverages or do you not? So that's categorical. So what we are asking here is we're trying to understand the parameter pi, and note that pi would be the percentage of all adult Americans who consume alcoholic beverages. Lastly, I'll just note what our sample statistic is. This is actually a very common error students make on a problem like this. The sample statistic here is going to be a proportion. It's not just the number 647. It's going to be the number 647 divided by 1,011, right? It's the proportion of your sample that said that they would consume alcoholic beverages. If you divide that out, you will find that it equals about 0.64. All right, notice before I even did Part A, I sorted all that sort of stuff out. I noted the given information and what symbol was being given to me. So the 1,011 is N. The 647 is just the number of successes in my sample, but I had to take that and turn that into p hat by dividing it by 1,011. I'm trying to kind of think about the big picture research question, which is trying to understand the value of pi, and I sorted out for myself the meaning of pi. I did all that before I even dove into the question. It's important that you take those intermediate steps. Those are like the things we discussed back in Unit 1, but you still need to be thinking about those things before you dive into these problems. So it says to use the 2SD method to find an approximation of the 95% confidence interval. So the 2SD method, remember, first step, we're going to use the formula to estimate the standard error. Since this is categorical, the formula we're using is square root of p hat 1 minus p hat over n. So plugging in our values, it'll be square root of 0.64 times 1 minus 0.64 divided by 1,011. Again, you could go to desmos.com and click on scientific. You click the big square root button, and then you hit the fraction button. And in the numerator, we'll put the 0.64 parentheses 1 minus 0.64. In the denominator, we'll put the 1,011. And it says that our answer is 0.015. I'm just going to go ahead and round that to 0.015. All right, that's the first step. Find the approximation of that standard error of the distribution of sample statistics. Second, we're going to double it. That's why it's called the 2SD method. It's 2 times that standard deviation of the distribution of sample statistics. So 2 times the 0.015, you'll get 0.03. What you have just found here is our estimate of the margin of error. So when you do the 2SD method, the 2SD is your estimate of the margin of error. Third, you can now build your confidence interval. You have everything you need. So our interval, in the center of our interval is always our sample statistic, which was 0.64. We have our margin of error, which is 0.03. So I add 0.03 and I subtract 0.03. So we have 0.67 on the upper end and 0.61 on the lower end. So our estimate, our 95% confidence interval estimate for pi is that it is 0.61 up to 0.67. That's our interval notation. Or we could write it as it's 0.64 plus or minus 0.03. Part B asks to write a complete sentence to interpret the meaning of that confidence interval in context. So when we say that pi is somewhere between 0.61 and 0.67, what do we really mean in context? Well, remember, pi represents the percent of all adult Americans who consume alcohol. So we can say that we're 95% confident that the true percentage of adult Americans who consume alcohol is somewhere between 61% and 67%. Says use the theory-based inference applet to get a 95% confidence interval. So we're now just going to check with our Rossmann chance applet to see if it also gives a very similar confidence interval than the one that we estimated with the 2SD method. So I'm going to the Rossmann chance applet. We go to our theory-based inference. We're doing categorical, so I select one proportion from the pull down. I select confidence interval, and I just put in our information. So recall our sample size was 1,011. And we had a count, meaning number of successes, of 647. Hit calculate, and boom, there's your answer. So we got 0.61 approximately up to 0.67, which is exactly what we said it would be with the 2SD method. Now, this theory-based approach does give us a little bit more accuracy, but honestly, if you were going to give a contextual sentence, giving this in real-world terms about adult Americans drinking alcohol, I don't need to go beyond saying 61%. It would be silly to go to say 61.04%. So it would be fine for you to round this to 61% and 67%. Part D reads, use the theory-based inference applet to get the 99% confidence interval. So we're just going to do a bit of a comparison here. So before we had this 95% confidence interval from the applet, all I have to do now is go in and change the 95% confidence level to 99% and hit calculate. And there it is. It says now we have a confidence interval that ranges from 60% up to 68%. Notice that this confidence interval is wider. It goes down a little further. It's going down to 60 instead of 61. It goes up a little higher, so it goes up to 68 instead of 67. It's casting a wider net. If you are saying that you are more confident that it's in a range, you need to cast a wider net. So for example, I'm 100% confident that the percentage of adult Americans that drink alcohol is somewhere between negative infinity and infinity. So if I'm going to be really confident, I have to cast a great big interval. But the less and less confident they get, the smaller and smaller your interval is. For example, I'm only like a teeny tiny bit confident that the percentage is between 70.1345 and 70.2196%. If I have a little tiny interval, I'm not going to be very confident that I captured the true population parameter within it. Part E, is the 99% confidence interval wider or thinner? So we just discussed that. The 99% interval is going to always be wider than the 95% interval, holding all other things constant. Tony claims that 70% of all adult Americans consume alcoholic beverages. What do you think of Tony's claim? So our confidence interval estimates, both of them, the 95 and the 99, do not include the number 70%. So we are pretty confident the true population parameter is actually less than 70%, right? We think it's somewhere between 61 and 67%, or maybe if we want to go to 99% confident, we're thinking it's between 60 and 68%. That doesn't include 70%. So we would conclude that we're not very confident that Tony is right. We actually have strong evidence that Tony is not correct.